First, we pull out the fractions. We have 3/4 that belongs to Cohen, and we have 3/6 that belongs to Dax. Our keywords today are who, because we're looking for who, not our fraction, and more. So we want to know who eats more of the fraction of their waffle. Watch as we finish our crisscross multiplication. We know that 4 times 3 is equal to 12, and 6 times 3 is equal to 18. Now we ask ourselves, who ate more? And we see that 18 is bigger than 12 or greater than 12. The alligator always eats the bigger numbers, so we know that Cohen ate more. And Cohen is our... I see a word problem with fractions in it. How about you? What do we do first? Pull out the fractions. I know that 6/6 belongs to Nora and 6/8 belongs to Jaden. What do we do next? We find the keywords. I find who because I have to write a name and not a fraction. And I find the word least because I'm looking for who has the least amount of their project finished. Now that I've pulled the fractions out and I know which fraction belongs to who, what do? Crisscross multiplication. We're going to start here with 6. I'm going to multiply it by the other 6. So I know that 6 times 6 is 36. I'm going to multiply 8 times by 6. I know 8 times 6 is 48. Or 6 went on a date with 8 and got to 48. I decide who is bigger, 48 or 36. I know my alligator eats the biggest number. And I remember that my keywords asked for who and had the least. So I see that 36 is smaller than 48. So I know that Jaden did the least amount of his project. Pulled out the fractions. I figured out which fraction belongs with which person. And I boxed the keywords. Who, because it's asking for a name, not a fraction. And more. Using crisscross multiplication, I found out that Daisy and Muataz have eaten the same amount. These fractions are equivalent. Let's try some of your own. Daisy eats 2/3 of her donut. Muataz eats 4/6 of his donut. Who ate more of their donut? Pulled out the fractions. I figured out which fraction belongs with which person. And I boxed the keywords. Who, because it's asking for a name, not a fraction. And more. Using crisscross multiplication, I found out that Daisy and Muataz have eaten the same amount. These fractions are equivalent. We are now going to be practicing writing the fractions in order from greatest to least. What do we look at first? The denominators. Are the denominators the same or different? Different. If the denominator's different, switch it. If the denominator's different, switch it. What do we switch? The directions. Remember, no longer are we going to write them from greatest to least. We are going to be writing them from least to greatest. Now I have to ask myself, looking at the denominators, which denominator is the least? The 2. Then comes the 6, then comes the 8. Am I done? No, I have to put back the numerators. Why does it work to switch the directions? Well, remember, the bigger the number, the smaller the piece. Now we're going to be practicing writing the fractions in order from least to greatest. What do we look at first? The denominator. What do we notice about all the denominators? 8, 8, 8. They're the same. Do we have to do anything fancy? No, we are just going to write the fractions in order from least to greatest. So looking at the numerators, which number is the least? A 1, and then a 3, and then a 7. Am I done? Nope. I have to put back my denominators. And now I have my fractions written in order from least to greatest. Let's practice again. We're going to write these fractions in order from least to greatest. What do we look at first? The denominators. We have an 8, a 2, and a 7. What do we know about these denominators? They're different. Checking the numerators, they're all the same. If the denominator is different, switch it. If the denominator is different, switch it. What are we switching? The directions. No longer are we going to write it from least to greatest. We're going to switch it, and we're going to write it from greatest to least. Covering up the numerators, which of those numbers is the greatest? An 8, a 7, which one's the least? A 2. So I write 8, 7, 2. Am I done? No, I have to put back the numerators. I've got a 2, and a 2. Voila, I've got my answer. How do I know that it's true? I remember, the bigger the number, the smaller the piece. Let's try ordering the fractions one more time. It says, Mrs. Bradshaw walks 2/3 of a mile on Monday, 2/6 of a mile on Tuesday, and 2/8 of a mile on Wednesday. On which day did she walk the least? I see a word problem with fractions in it. What should we do? Pull out the fractions. I see 2/3 is on Monday, 2/6 of a mile on Tuesday, and 2/8 of a mile on Wednesday. Let's find the keywords. My keywords are which day, which tells me I need to write the name of the day instead of the fraction, and the word least. So I'm looking for the smallest fraction. Let's pull out the fractions. Now that I've pulled out the fractions and labeled them on which day they represent, I know that I have to find the fraction that's the least. So I'm going to write these fractions in order from least to greatest. What do I look at first? The denominator. So I've got a 3, a 6, and an 8. What do I see about these denominators? They're different. If the denominator is different, switch it. If the denominator is different, switch it. No longer am I going to write this in order from least to greatest. I'm going to flip it and write it in order from greatest to least. So looking at this, I'm going to ask myself, which of those denominators is the greatest? An 8, a 6, and which one is the least? A 3. So I write 8 for the greatest, a 6, and a 3. And am I done? Nope, I have to put back the numerators. So I put the 2 back, and the 2 back, and the 2 back. Now I can ask myself, which fraction is the least? And I know that 2/8 is the least fraction. Now I'm not done yet. What do I do first? Count the spaces. So I've got 1, 2, 3, 4. Remember, I don't count this space because I only look at 0 to the 1. Now I ask myself, if there are 4 spaces, where does that number 4 go? In the denominator. Every fraction number line always starts with a 0. So I'm going to make this 0/4, 1/4, 2/4, 3/4, 4/4. I know that 4/4 is equal to 1 whole. And I come over to the A, and I notice that A is on 2/4. Fractions on a number line. What do I do first if I was looking for point A? I count the spaces. So, starting at 0, I've got 1, 2, 3, 4, 5, 6, 7, 8. I go from 0 all the way to the 1. I don't count anything past the 1. Every number line always starts with a 0. So I'm coming back over here. Because I had 8 spaces, I'm going to put an 8 in my denominator. So I've got 0/8, 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. I know that 8/8 is equal to 1 whole. Coming over to point A, I see that point A is equal to 2/8. And coming over here to point B, I find that point B is equal to 7/8. So I've got B is equal to 7/8. And voila, I have my answer. Next question, what fraction lies at the number 1 on the number line? What do I do first? Count the spaces. I know that every number line starts with a 0, so I count 1, 2. I count this space or this space because I remember that I stop at the 0, from the 0 to the 1. So I have 2 spaces. I'm going to put a 2 in the denominator, so I know that this is 0 halves, and this is 1 half, and this is 2 halves. And when I know the number on the top is the same as the number on the bottom, so I know my answer is 2 halves, which is equal to 1 whole. This question says, what fraction lies on the number 2 on the number line? Now remember, this one's a little bit different because we are going past the first whole number. So we are not counting the spaces on this one. We do just have to remember what that fraction line means. So I'm going to take that whole number and I'm going to put it on top of my fraction line. I remember that the fraction line means to divide. So I have to ask myself, 2 divided by what is still going to be equal to 2? That's right, 1. So my division equation would be 2 divided by 1 is equal to 2. So I know my fraction would be 2 over 1. The same would hold true if I was asking you what point number 3 was laying on, what fraction number 3 was laying on. I would put 3 over 1, and I'd put 4 over 1. And I can prove it by saying that 3 divided by 1 is still going to be equal to the whole number of 3, or 4 divided by 1 is still going to be equal to the whole number of 4. Fractions are fractions that are, or that represent the same amount of space. So equivalent basically means the same. So what if I wanted to find an equivalent fraction for 1 whole? Remember that when I have a fraction where the number on the top is the same as the number on the bottom, it is equal to 1 whole. I could always check this by using this line right here as a division symbol. So I would say 4 divided by 4 is equal to 1. What if I wanted the fraction to be equivalent to 3 wholes, or the number 3? I could check myself by asking, if I take the top number and I divide it by the bottom number, does it equal 3? So does 18 divided by 6 equal 3? Yes. If I were given this fraction, 8 halves, is 8 divided by 2 equal to 3? No, 8 divided by 2 is equal to 4, so I know that this fraction would not be equivalent to 3. What if we wanted an equivalent fraction for the whole number of 4? Which one of these fractions, or how many of these fractions, is actually equivalent to 4? So let's check ourselves. Remember that this sign is going to be used as a division symbol, so I would say that 8 divided by 2 is equal to 4. So I would say that this fraction works. Going to the next one, again, that line is going to equal division sign. So I would say 16 divided by 4 is equal to 4. So again, this one would work. And if I was looking at this third fraction, remembering that that line means to divide, I would say 12 divided by 4 is equal to 3. So I know that this fraction is not equivalent to 4. Last review of equivalent fractions. What if it asks, which fraction is equivalent to 2/8? Remember, again, I'm going to pull out my fraction, 2/8. 2/8, and use crisscross multiplication. So once again, I'd go 6 times 2, which is equal to 12, and 8 times 3, which is equal to 24. I know that 24 and 12 are not equal, so I know that 3/6 is not an equivalent fraction. Again, I would pull out the fraction 2/8. I'd work on crisscross multiplication. I know that 4 times 2 is equal to 8, and I know that 8 times 1 is equal to 8. I know that 8 is equal to 8, so I know that 1/4 is equivalent to 2/8.